Hello friends, in some of our previous sessions we have seen basic concepts of derivatives, and we have also seen something called as the derivatives of standard functions and composite functions. We are going to now move ahead with some more questions on understanding the derivatives of composite functions. So students, welcome all to this channel, Pankaj Lade. In today's session we are going to see some more questions, some more numericals on composite functions. So let's begin ahead with the concepts. So if you remember, we have seen some of basic concepts and one or two particular questions based on the concept of composite functions. Let's move ahead with some more examples. Now, if I take, say, y is equal to tan x. I have taken a function y is equal to tan x. So do you remember that it is very easy to identify a standard function? If you have a variable x, tan x, that becomes a standard function. So now if I write, say, y is equal to root of tan x, getting or not? It is root of tan x. So now what has happened? This has become a composite function. It is not root. See, if I write only tan x, then it becomes a standard function. But is it only tan x? No, it is root of tan x. Some addition has been happened over there. So that is called as a composite function. But now you also need to understand what kind of a composite function it is. Now observe carefully. Do you know what is the derivative of tan x? Dy by dx becomes derivative of tan x becomes sec square x. We all know. So if I want to get the derivative of root of tan x, how would I do it? Now observe this technique, this trick. Whenever you want to identify composite functions, how do I begin? How do I start to get the derivatives? So I'm going to write derivative dy by dx. Then I write d by dx of, what is your function? It is initially root, isn't it? The very first thing that you see is a root. So that root becomes your function. Root of tan x becomes your composite function, but the root is your first function. Inside the root, whatever you have, inside the root, whatever you have, is it x? Because we know that root of x is our standard function, isn't it? So is it looking like root of x? But in place of x, what do you have? You have tan x. So I'm going to call this tan x as u. I'm going to call tan x as u. So I'm going to hide this tan x for some time, isn't it? So that becomes root of x, root of u. What is derivative of root x? It was 1 upon 2 root x. So I'm going to get the derivative here, derivative of root of tan x, it becomes derivative of root x. So I'm going to write here y is equal to root x, then dy by dx becomes equal to 1 upon 2 root x. So I can get here root, in place of x I can see tan x. So I'm going to use a formula of root x, which is 1 upon 2 root of x. But is it x? No, it is tan x. It is u. So 1 upon 2 root of u, which is tan x, and again d by dx of u. You have to know the concept of composite function, the theorem that I have discussed in previous session, that if y is a function of u and u is a function of x, then y is directly depending on x through u. So dy by dx becomes equal to dy by du into du by dx. Same way here, the first function is root and then tan x is taken as u. So derivative of root u is 1 upon 2 root u into again the derivative of u. So again derivative of tan x. So what's the derivative of tan x? You remember it was sec square x. So my answer comes sec square x upon 2 root of tan x. So that is what the derivative of root of tan x is. It is sec square x upon 2 root tan x. Make sure as and when the video is proceeding, you are also noting all these things down in your notebook. So let's move on ahead with another function. So I had y equal to root of tan x. If I change it to some other function, let us say y is equal to, if I now write tan of root x. See, root of tan x, now it is tan of root x. So now what's the first function? So d by dx of tan of root x. So who's the first thing that you can see? It is tan. Then can you see tan x? No, I can see tan root x. So it is a composite function because of what? Root x. So tan x becomes my standard function, tan root x becomes my composite function. And why is it composite? Because of root x. If it was tan x, then it would have become a standard function. So I'm going to call this root x, I'm going to hide this root x for some time, I'm going to call it as tan u. So what is derivative of tan u? So derivative of tan u would be sec square u. What is u? It is root x into again the derivative of u, which was root x. Knowing the theorem will be very helpful here. Make sure that you revise your theorem again and again and then apply the concept here. So tan u, this was taken as u, derivative of tan u, sec square u into derivative of u. So derivative of root x. Is root x a standard function? The answer is yes. Root x is a standard function. So its derivative is going to come sec square root x into derivative of root x, which is 1 upon 2 root x. So that's your formula for what? That's your answer for what? The function was y is equal to tan of root x. Let's take one more. Let's move ahead. So make sure you are also noting down these questions, isn't it? So that will help you to understand the concept in a more better way. Suppose if I give you y is equal to sine cube x, I'm going to get the derivative of y is equal to sine cube x. Now what general perception about such kind of problem is, usually people think that if derivative of sine x is cos x, we know derivative of sine x is cos x, then derivative of sine cube x will become cos cube x. This is absolutely wrong way of getting the derivatives. You have to know your basic concepts. When you take sine cube x, it is actually what? It is sine x the whole cube. That is what your function is. That means when you say differentiating both sides, when you write dy by dx, it is d by dx of what? Sine of x the whole cube. So what's the first thing that you see? You don't see sine x, you see a bracket whose power is 3. That means you are actually observing x cube. That is what you need to understand. You are actually observing x cube. But is it x? No, it is not x. It is sine x. So I'm going to hide this term. Getting or not? I'm going to hide this term. I'm going to call this as u. So that becomes u cube. So what was derivative of x cube? So I can now get the derivative of x cube. Derivative of x cube like x raised to n. X raised to n. The derivative is n. X raised to n minus 1. 3 x raised to 3 minus 1. So that's 3x square. Is this x cube? Although it is not x, isn't it? It is sine x. I'm going to call it as u. So what is u cube derivative? 3u square. 3x square. What is in place of u? It is sine x. I write 3 sine x square into again the derivative of what? U. So make sure this point goes into your mind like a rocket. Remember, you have to know your concepts first and then you can apply it into the question. So this was u cube. Derivative of u cube is 3u square. Again derivative of u. So derivative of sine x. Getting or not? So what is derivative of sine x? It is cos x. So I write 3 sine square x into cos x. That's the formula. That's the answer for derivative of sine cube x. 3 sine square x into cos x. Make sure, again, as I'm telling again and again, you have to keep on noting down these solutions. Okay, let's move ahead. Let's get the derivative of, say, cos square x. Let's try and get the derivative of cos square x. I want to get the derivative of cos square x. So I can write dy by dx, d by dx of, this is cos x the whole square. Remember, cos square x can be written as cos x the whole square. So what's the first thing that you can see? You see a bracket, and this bracket has what power? 2, isn't it? So this can be treated as x square. But is it x? No, it is not x, it is cos x. So let's hide it for some time. Let us call it as u. So it's u square. What is derivative of x square? The derivative of x square is 2x. So what could be derivative of u square? It will be 2u. So I'll write 2 and u, which is cos x. But again the derivative of u has to be taken. So d by dx of u, which is cos x. And don't you know that cos x is a standard function and its derivative is going to come minus sin x. So I get 2 cos x into minus sin x, or I can say minus of 2 sin x into cos x. And I hope you all know that from trigonometry the formula for 2 sin x into cos x is sin 2x. So I get minus of sin 2x. Is that part very well understood to everyone? Isn't it? So these are some simple questions that I've taken to understand the composite. So now we have seen some of the previous questions. Let's now move on with some more questions. We will try to cover a question of every single type. For instance, if you look at the list of the questions that I have written, these questions will cover most of the types of the composite functions. If you observe, this is with a plus sign, root cos x plus root of cos root x. So that will cover the u plus v rule or the u minus v rule. Further you can observe there is cot x cube into sin square x raised to 5. This will cover your u into v rule. Then you have sine of root of x. That will of course cover your composite function concept. Then you can see there is 4 log of sec x to the base 2 and minus 9 log of tan x to the base 3. This will need obviously some basic knowledge of mathematics, means the basic knowledge of logarithms. Further if you observe there is log of x to the base 7 the whole to the base 5. This will need the knowledge of logarithms again. Further you have u upon v rule, isn't it? Then again you can see there is a log term. So these all questions that I have written, these will more or less cover maximum number of concepts of derivatives. So let's begin one by one. So the first question, let's begin with the first question. So we have root of cos x plus root of cos of root x. So I'm going to write the question first. So we have y is equal to root of cos x plus root of cos of root x. So I want to differentiate this. Now the basic way of writing a particular question is somehow like this. Observe, I'm going to write like this: differentiate both sides. So BA stands for both sides, WRT, that's with respect to x. So I'm going to write differentiate both sides with respect to x. So I get dy by dx is equal to d by dx of your question, which is root of cos x and root of cos of root x, and you close your bracket. Now we have already seen, or we already know that derivative of u plus v. So I can call this as u and I'm going to call this as v. So derivative of u plus v, it is going to be derivative of u, then the plus sign and derivative of v. That means I can write d by dx of root of cos x, the first term, and then plus d by dx of root of cos of root x, the second term, isn't it? So now let's try and differentiate, let's try and understand whether it's a composite function or not. So observe carefully. I want to get derivative of root of cos x. So at the beginning derivative I can see root, isn't it? I can see a root sign. Whatever is present inside is a term of x. It is not x. We know that the standard function is root x. It is not root x. It is root cos x. So the first function that I'm seeing here is root. That means this can be treated like root u. Now we know that the derivative of root x, if you remember, it is 1 upon 2 root x. So derivative of root u becomes 1 upon 2 root u, which is cos x here, into again the derivative of u, which is cos x, isn't it? This concept has to be well understood. The function was root x, but I do not see x here. I see cos x. That means it's a composite function. So I will treat it like root u, and derivative of root x was 1 upon 2 root x. Derivative of root u will be 1 upon 2 root u. Again you have to differentiate u with respect to x, because you want to remember that the differentiation is carried with respect to x, not with respect to u. If I would have asked you to differentiate with respect to u, then my derivative would have been 1 upon 2 root u. So if a function of u gets differentiated with respect to u, then the answer would definitely would have been 1 upon 2 root u. But I am differentiating x with respect to, the function is u, and I am differentiating with respect to x. Hence my derivative would be 1 upon 2 root u, and again the derivative of u with respect to x. So d by dx of cos x plus. Now again I see a root sign, isn't it? Whatever is present inside will be all hidden for some time, isn't it? You treat it like a function of x. I'm going to call it as u again. So what is derivative of root u? 1 upon 2 root u. What is in place of u here? It was cos root x. So again derivative of d by dx of cos root x. Is that part well understood to everyone, isn't it? Now derivative of cos x, that's a standard function. We all know that derivative of cos x is minus sin x. So I'm going to write the derivative as minus sin x upon 2 root of cos x. Well understood to everyone, isn't it? Then over here if I come, now I see derivative of again cos. But it is not cos x, it is cos something in x, isn't it? So that becomes a composite function. So I'm going to hide this something in x for some time. So I'm going to read it as cos u. And what is derivative of cos u? It will be minus sin u and again the derivative of u. So my answer would be again minus sign, because derivative of cos came what? Minus sign. So this plus becomes now minus. Minus sign of derivative of cos u is minus sin u. So I write minus sin u, which is root x, upon I have 2 root of cos of root x into, now I'm differentiating cos u with respect to x. Derivative came minus sin u. So I should again differentiate u with respect to x. So d by dx of the u, which is root x here. So this chain rule, this knowledge of composite function is very helpful. Only then you would be able to get the correct answers of the composite functions derivatives. Now finally, derivative of root x. Root x is again a standard function, we all know. So its derivative is simply going to be 1 upon 2 root x. So my final answer would look like this: minus sin x upon 2 root of cos x. Then there is a minus sign. Then I have sine of root x upon 2 root of cos root x, and the derivative of root x came 1 upon 2 root x. So that is what the answer is going to look like. At the end, what you can do is you can multiply this 2 and 2 and make it 4. So this is how we can get the answer of root cos x plus root of cos root x. That was my first question. In this question we have covered u plus v, as well as we have covered the knowledge of composite function. Now I hope you are all noting down these all solutions simultaneously. Make sure that you are noting down the solution, isn't it? So I'm going to erase it out from here and we will move to the next question. Okay, so let's remove the solution here. Make sure that you have noted down the entire solution very properly in your notebooks, and we will move to the next question. So now when you see the next question, you can observe there is cot of x cube plus cot of x cube into sine square x raised to 5. So I'm going to write the question first. So I have y is equal to cot of x cube into sine square x raised to 5. So again I'm going to start the same way. I'm going to differentiate both sides with respect to what? With respect to x. So I'm going to differentiate both sides with respect to x. So I get dy by dx is equal to d by dx of cot of x cube into sine square x raised to 5. Now you need to understand there are two different functions of x over here. The first function is cot of x cube, isn't it? That is a function of x, term of x, and the other one is sine square of x raised to 5. So this is u and this is v. So it looks like u into v. I hope you already know that u into v, the answer, the formula for u into v, it is given by v as it is derivative of u, isn't it, plus u as it is derivative of v. That's the formula for u into v. Second function as it is derivative of the first function plus first function as it is derivative of the second function. So I'm going to get my answer as derivative of u into v becomes second function as it is. So I write sine square x raised to 5 as it is into the derivative of cot of x cube, isn't it? Then write a plus sign because u into v gives me derivative, or the first function as it is, derivative, sorry, second function as it is, derivative of the first function plus first function as it is, derivative of the second function. So here second function was sine square x raised to 5, I have written it as it is, derivative of the first function plus first function as it is, that is cot of x cube as it is, and derivative of sine square x raised to 5. So let's now move on to get the derivatives. Now when you see here derivative of what? Cot. The very first function you can see is derivative of cot itself. Cot, the derivative, if you remember from the standard functions, derivative of cot x is minus cosec square x. But did you observe here, is it cot x? It is not cot x. We know that the standard function is cot x. This is not cot x, it is cot something of x. That becomes a standard, that becomes a composite function. So what I'm going to do here is I'm going to remove this x cube for some time. I'm going to read it as cot u. So what is derivative of cot x? It was minus cosec square x. So what would be derivative of cot u? It is going to be minus cosec square u into again derivative of u. So my answer would be the first term as it is. So I write sine square x raised to 5 as it is. Derivative of cot, it is minus cosec square u, which is x cube into again the derivative of x cube, isn't it? So that's the derivative of the first function. Let's move ahead with the next one. So I have plus cot of x cube into, what do you see here? Now many of the students usually feel that derivative of the first function is sine. Students, this is what you have to pay attention for. The first function is not a sine over here. You got to have a very close eye on the functions. Observation is very important. The first function is not sine, even though you can observe that the first term written over is sine. It is very confusing. So I would write here, observe how the terms are written. So d by dx of it is sine square. So it is actually sine of x raised to 5 and the whole square. So this is how the term of sine square first needs to be written, and then you are going to differentiate. So now if I observe, what's the first function I observe? What's the first function I see, I encounter? It is a bracket and it has a square. So it can be now read as x square. Isn't it? Something in terms of x and you are doing square. But is it x? No, it is not x. It is sine of x raised to 5. So it will be treated as u. So u square, the derivative of u square is going to be 2u and again derivative of u. So let's move on ahead. My next step is going to be sine square x raised to 5, the first term. Then it is multiplied with minus of cosec square. So this negative sign is going to come here behind. So I'm going to write minus sign over here at the beginning. Then cosec square x cube. So I write cosec square x cube, and then derivative of x cube, that's a standard function, x raised to n. So x raised to n, its derivative is going to be n, x raised to n minus 1. So I write here 3x square, isn't it? You know the derivatives formula very well by now. So x cube derivative is 3x square. Now let's move ahead. I can write plus sign, then there is a cot of x cube. So I write cot of x cube here. And then derivative of something square, it is u square. So what's derivative of u square? It is 2u and again derivative of u. So that's 2 into u, and u was sine of x raised to 5. This entire thing has hidden. It has been written as u square. That's 2u into again derivative of u, which is sine of x raised to 5. Sine of x raised to 5, isn't it? Now this answer is going to be, this entire thing can be now simplified and written as minus 3x square sine square x raised to 5 into cosec square x cube. That's my first term. And then let's move on to the next term. So that's plus here. I'm going to write 2 at the beginning. Then cot of x cube, let's write it down. Cot of x cube. So let's write cot of x cube here. and into sine of x raised to phi. And now I'm going to differentiate. What the first thing that I can see over here is sine. Now there is only sine, and then inside the bracket, inside the angle of sine, I see x raised to phi. So the first function is sine. So derivative of sine, it is what? It is cos. But is it sine x? It is not sine x. It is sine of something in x. So again, that something in x will be treated as what? It will be treated as u. So what's derivative of sine u? It is cos u. Again, derivative of u. So I write cos u, which is x raised to phi, into again derivative of x raised to phi. So the final step that is left is to get the derivative of x raised to phi. That is the only derivative left, isn't it? All the places the derivative has been vanished. So when you move to the last step of this, I would write this line first of all, then I write this 2 cot x cube sin x is to phi and cos x is to phi. All of the things are definitely going to come, and finally I'm going to get the derivative of x raised to phi. So doesn't it look like the standard function x raised to n, and the derivative of x raised to n, it was n x raised to n minus 1. So what's the answer for this particular term I'm going to get? X raised to phi derivative is 5 x raised to 4. So I am a little bit less on the space, so that's why I'm writing this particular step over here, and I hope you will definitely write the final step, which is the final answer for this particular question. So in this question we have what you can say, we have taken u into v rule, we have completed u into v rule, as well as we have taken the composite function. So the first concept that we learned today was u plus v and the composite function. The second concept we have learned is u into v and the composite function. Let's move ahead. So now what I'm going to do here is this sine of root x. I can now sense that you people must have pretty well understood all the concepts of the composite function. So whenever you learn, you acquire a new set of knowledge, you acquire some new concepts. It is mandatory that you have to give some amount of practice on your own to inculcate that knowledge into you. So it becomes very important to have a good practice. So what I'm going to do here is I'm going to give this particular problem, sine of sine root x, as a practice for you. Make sure that you solve this question, sine of sine root x, and you can post your answers in the comment section. So if there is something wrong into your solution, I will definitely get back to you with the correct answer for this. So make sure that you give a good amount of practice for this problem. Of course, you have to note down these solutions also, as and when the video is proceeding. Make sure that you are also writing down the solution. Okay, so that was your second question. The third I'm giving for practice. Let's take the fourth one. Now I'm going to erase this part from here, and then we will move to the next question, where I will need some basic concepts of logarithm. So knowing logs and its property becomes a mandatory skill. You have to know basic knowledge. You have to have the basic knowledge of logarithms in order to solve problems on logarithms. Now, before I go to the question, of course I want to evaluate this answer, but before I go to the question, I'm going to write one very important property over here. The property is very, very, very important. Make sure that you include this property as a formula somewhere in your notebook. Now, the property goes like this. You remember that e raised to log x. Now, do you also recall whenever in calculus, if I am saying log x, logs are always with a base. Remember that there is no term of log without a base. A base has to be present, and if the base is not written, that means by default the base is taken as e in calculus. So e raised to log of the base is e here. So e raised to log of x and the base is e. The answer simply turns out to be x. Observe carefully. So this is what you can say a index, isn't it? It is an indices form. E raised to. This is called as the base. That means the base of this exponential form is e, and the base of the log is also e, isn't it? The base of the log. Base of the log, that is also e. So when the base of the exponential form and the base of the log, they are both same, you simply get x back here. So this is true for any given positive number. Positive number I said, so this is very important. So a raised to log of x to the base a. So observe the exponential term has base a and the log also has base a. I can simply write the answer as x. So two very important formulas. You got to note them down somewhere in your notes, so that whenever it comes again sometime later, you will be knowing the formulas, you will be knowing the concepts. Now let's take this question. So we have y is equal to 4 raised to log of sec x to the base 2. Now let's take the two terms individually. Let's try and get the answers for the two terms individually. We have 4 raised to log of sec x to the base 2. Now observe carefully, it is 4 raised to log of sec x to the base 2. So log has what base? The base is 2. And the base of the entire exponential term is 4, isn't it? So right now it seems that there is no relation between the two terms. But if you have a very close eye, if you start observing, 4 can it be written as 2 square? So I'm going to write 2 square and bracket raised to log of sec x to the base 2. Now if you observe this 2 square and then raised to some log, do you remember that a raised to m whole raised to n can be written as a raised to m into n? So the m and n can be multiplied. So here also 2 raised to 2 raised to term of log. This 2 can be multiplied here. That means I can write 2 raised to 2 log of sec x to the base 2. Now further you should be also remembering that log of a raised to m becomes m into log a, isn't it? You remember that log of a raised to m is m log a. So this is 2 into log of something. So this 2 can be brought to the power, isn't it? So I'm going to write 2 raised to, this 2 will go to the power of sec. So I write log of sec x the whole square to the base 2. So did you now observe? This log has base 2 and the entire exponential term also has base 2. So the final answer can be simply written as sec x the whole square, isn't it? That means the answer for 4 raised to log of sec x to the base 2 simply came to be what? Sec x the whole square. Now what I'm going to do here is I'm going to erase again some part from here and let us write for the other term, which is 9 raised to we have log of tan x to the base 3. Again, if you observe 9, can it be written as 3 square? So I would write 3 square and then a bracket and then log of tan x to the base 3. Further, it looks like a raised to m and whole raised to n. So a raised to m whole raised to n is a raised to m into n. So I'll be writing here 3 raised to 2 log of tan x to the base 3. Now again the 2 can be taken to the power, so the steps are exactly same as what we have learned here. So I'm going to be a little bit fast over here. So 3 raised to, I'll write log of tan x to the power 2 to the base 3. So again if you observe, log has the same base 3, the exponential term also has the base 3, both the bases will cancel each other and you simply get the answer as tan x the whole square. So now if you take your question, in your question the answer for 4 log of sec x to the base 2, 4 raised to log of sec x to the base 2. So I'm going to write my question. So y is equal to, I have 4 raised to log of sec x to the base 2 minus 9 raised to log of tan x to the base 3. What did I get for the first term? The answer came to be sec square x, isn't it? Sec x the whole square, or I write sec square x minus the next term came tan x the whole square, which I can write tan square x, and you all very well know that sec square x minus tan square x, the answer is 1. That means you get y is equal to what? 1. And now do you observe that y is equal to 1? Y is equal to 1 is a constant function, and we all know that the derivative of the constant function will always be what? It is going to be 0. So if I differentiate y with respect to x over here, the answer is going to come 0, because y is equal to 1 is a constant function. So that was my Solution for the problem 4 raised log of sec x to the base 2 minus 9 raised log of tan x to the base 3.